Now let us talk about requirements modeling in much more detail. So first of all, we'll look what is requirement modeling. So requirements modeling uses combination of text and diagrammatic forms to depict requirements in a way that is relatively easy to understand and straightforward to review for correctness, completeness and consistency. So software engineer basically is responsible for requirement modeling, who builds the model using requirements captured from the customer. Requirements analysis is another phase in this requirement modeling, which results in the specification of software's operational characteristics, indicates software's interface with other system elements, and establishes constraints that software must meet. Requirements analysis allows to elaborate on basic requirements established during the inception, elicitation, and negotiation tasks that are part of the requirements engineering. The requirements modeling results into following types of models. One is scenario-based models of requirements from the point of view of various system actors. Class-oriented models that represent object-oriented classes which contains attributes and operations, and the manner in which classes collaborate to achieve system requirements. Third requirements modeling is behavioral and patterns based models that depicts how software behaves as a consequence of external events. Fourth one, a data model that depicts the information domain for the problem. So the data model contains flow-oriented models that represent the functional elements of the system and how they transform data as they move through the system. The requirements model must achieve three primary objectives. The first one is to describe what customer requires. Second, to establish a basis for creation of a software design. And third, to define a set of requirements that can be validated once the software is built. Let's look into the rules of thumbs for analysis. A number of rules of thumbs that should be followed when creating the analysis model. The model should focus on requirements that are visible within the problem or business domain. The level of abstraction should be relatively high. Each element of the requirements model should add to an overall understanding of software requirements and provide insight into the information domain, function, and behavior of the system. Delay the consideration of infrastructure and other non-functional models until design. For example, a database may be required, but classes necessary to implement it, the functions required to access it, and the behavior that will be exhibited as it is used should be considered only after problem domain analysis has been completed. Effort should be made to minimize coupling throughout the system. Be certain that the requirements model provides value to all stakeholders. Keep the model as simple as it can be. In requirements modeling, how are analysis patterns and classes recognized? That is the first thing which comes into mind. So who defines them, categorizes them, and readies them for use on subsequent projects? The answer to these questions lie in the domain analysis, which is described as software domain analysis is the identification, analysis, and specification of common requirements from a specific application domain, typically for reuse on multiple projects within that application domain. So when we talk about object-oriented domain analysis, we do the identification, analysis, and specification of common reusable capabilities within an object-oriented domain in terms of common objects, classes, and subassemblies and frameworks. The goal of domain analysis is straightforward, that is to find or create those analysis classes or analysis patterns that are broadly applicable so that they may be reused. The role of the domain analyst is to discover and define analysis patterns, analysis classes, and related information that may be used by many people working on similar but not necessarily the same applications. You can see here the schematic of domain analysis. In domain analysis, you have to define the domain to be investigated, collect a representative sample of applications in the domain, analyze each application in the sample, and develop an analysis model for the objects. You can say these are the sources of domain knowledge like technical literature, existing applications, customer surveys, expert advice, and current and future requirements. The output of the domain analysis is the various class taxonomies, reuse standards, functional models, domain languages, which is termed as a domain analysis model. Requirements modeling has different approaches. One view of requirements modeling, called structured analysis, considers data and the processes that transform the data as separate entities. Structured analysis is a data-oriented approach to conceptual modeling. Data objects are modeled in a way that defines their attributes and relationships. Processes that manipulate data objects are modeled in a manner that shows how they transform data as data objects flow through the system. There are different primitives for this particular type of modeling. So processes, data flow, data store, external entity, these are the basic primitives. So processes are nothing but an activities that transform the data, which are related by data flows to other processes, data store and external entities. Data flow indicate passage of data from output of one entity to input of another. Data store is a place where data is held for later use. Data stores are passive. No data transformation are performed on the data. External entity is an activity outside the target system. External entities cannot interact directly with the data stores. Second approach to analysis modeling is called object-oriented analysis, which will be looking into much details hereafter. So, which focuses on the definition of classes and the manner in which they collaborate with one another to effect customer requirements. The various model primitives which are being almost you know about it. So, the objects, classes, attributes, and the relationships. Objects is an entity that has a state, attributes and services interested in problem domain objects for requirements analysis. Classes provide a way of grouping objects with similar attributes or services. Classes form an abstraction hierarchy through each a relationships. We will see all these relationships in detail in coming lectures. So attributes together present an object state, may specify type, visibility and modifiability of each attribute. There are different types of relationship. One of them is a classification relation and a part of assembly relationship. Object-oriented analysis has a standardized meta model which is being represented by use case diagrams, class diagrams, activity diagrams and state diagrams. Let us talk about different types of element model. Like scenario based element model depict how the user interacts with the system and the specific sequence of activities that occur as software is used. The next is the class based elements model, in which the objects that the system will manipulate, the operations that will be applied to the objects to effect the manipulation, relationships between the objects and the collaborations that occur between the classes that are defined. Next is behavioral elements model. It depicts how external events change the state of the system or the classes that reside within it. Another type is a flow-oriented elements model, which represents the system as an information transform, depicting how data objects are transformed as they flow through the various system functions. Like you can model these software requirements by various types of models. Like first one is the scenario based models, which is being represented by use cases and user stories. Another is the class model, which is being represented by class diagram, collaboration diagram, composite structure diagram, etc. Then third one is the behavioral elements model, which can be represented by making use of state diagrams, sequence diagrams, like behavior of the system is being captured. And in the flow model, one of the example for the flow model is the data flow diagrams and different data models, which we will be looking in brief. So we will be focusing more upon scenario based models and after that class models in this particular part. Let us see details of scenario based modeling. For better user satisfaction, software team has to properly characterize requirements and build meaningful analysis and design models, and hence requirements modeling with UML begins with the creation of scenarios in the form of use cases, activity diagrams, and swim lane diagrams. Let us see first how we can build a scenario using creating a preliminary use case. What is use case? Use case is a contract for behavior, and the contract defines the way in which an actor, that is nothing but an external entity, uses a computer based system to accomplish some goal. Use case captures the interactions that occur between producers and consumers of information and the system itself. Let us see how the use cases are developed as part of the analysis modeling activity. Use case describes a specific usage scenario in a straightforward language from the point of view of a defined actor. If use cases are to provide value as a requirements modeling tool, the following questions must be answered. Number one is what to write about the use cases. How much to write about it? How detailed to make your description? And how to organize the description. Let's try to answer all the questions which we have raised previously. So what to write about? The first two requirements engineering task, inception and the elicitation, will provide you with the information you will need to begin with writing the use cases. So to begin developing a set of use cases, the list of functions and activities to be performed by a specific actor has to be mentioned. This can be obtained from a list of required system functions through conversation with stakeholders or by an evaluation of activity diagrams developed as part of requirements modeling. Before we solving the various questions like which we have seen here, what to write about, how much to write about it, how detailed to make your description, and how to organize the description, we will look into this particular case study of the safe home surveillance system. So to find out the solutions to the questions on use case development as part of the analysis modeling activity, pause this video and read the description on safe home surveillance system provided in the next few slides carefully. This case study will be used for the illustration purposes throughout the topic. The detailed description, you can read this detailed description over here. So safe home system has three big functions: security, surveillance, and home management. So as per the description above, we can see here there are three major functions in this particular safe home surveillance system. First one is the home security, and in which the various sensors are being used like water sensor, pressure, smoke sensor, window sensor, and everything. So the all these sensors are being attached to a hardware, and the data is being sent from all these sensors to the hardware, and hardware basically manages all these sensors by checking their statuses. Next major function is the home surveillance systems. So there are home is being monitored by using different cameras. The recording is being sent back to the hardware, and the hardware actually gives the control instructions to these various cameras. And third one is the home management. So in home management, the end user basically can check the data on his mobile phone or through a web. So end user can give the instructions. End user can monitor the whole surveillance system information on his either app or through web. So the data which is required for this app to be sent which is received by this hardware, the instructions are being given to the hardware by the server. So to what to write about this particular use cases. So reading the previous description and taking the excerpts out of this or extract the related information for the use cases or various functions. The safe home surveillance system function are being discussed, which identifies the following functions that are performed by the homeowner actor. So these are the various functions which are being listed over here. These are the informal functions being written and can be used as use cases. So in general, use cases are written first in an informal narrative fashion. If more formality is required, the same use case is rewritten using the structured format. The answer to the question what to write about is like you have to write an informal narrative use cases from the description given. As a further conversation with the stakeholder who plays the role of homeowner, and the requirements gathering team develops use cases for each of the functions noted. So use cases are written first in an informal narrative as we have already seen. So if more formality is required, the same use case is rewritten using the structured format similar to the one which is presented right now here. So you can see here the use case which is written in the structured format for the actor homeowner, and the use case is access camera surveillance via internet and display camera views. So these are the various steps. Like the first one is the homeowner logs onto the safe home product website. Then the homeowner enters his or her user ID. Likewise, the steps are being performed. Like sixth one is the homeowner selects pick a camera, and the system displays the floor plan of the house. The homeowner selects a camera icon from the floor plan, and lastly the system displays video output within the viewing window at 1 frame per second. So this is how the use case is being completed. Use cases of these types are sometimes referred to as a primary scenario. Now, third step is refining a preliminary use case. So, for previous question, how much to write about, that we have seen, like there are some primary scenarios we should talk about and we should write about, and then we will see how detailed this particular use case description can be made by refining a preliminary use case. So, a description of an alternative interactions is essential for a complete understanding of the function that is being described by a use case. Therefore, each step in the primary scenario is evaluated by asking the following questions. Can actor take some other action at this point of time? Is it possible that the actor will encounter some error condition at this point? If so, what might it be? Is it possible that the actor will encounter some other behavior at this point? For example, behavior that is invoked by some event outside the actor's control. If so, what might it be? Considering the previous example, we know the step number 6 and step number 7 which I have taken out over here. So consider the step 6 and 7 in the primary scenario presented earlier. The homeowner selects pick up camera and the system displays the floor plan of the house. Secondary scenario can be like view thumbnail snapshots for all cameras. A, a brainstorming must be held to derive a reasonably complete set of exceptions for each use case. In addition to the generic question, the following issues should also be explored. Are there cases in which some validation function occurs during this use case? So this implies that the validation function is invoked and a potential error condition might occur. So are there cases in which a supporting function or actor will fail to respond appropriately? For example, a user action awaits a response but the function that is to respond times out. Can poor system performance result in unexpected or improper user actions? So, for example, a web-based interface responds too slowly, resulting in a user making multiple selects on a processing button. So these selects queue inappropriately and ultimately generate an error condition. So during the refining of delivery use case, we need to think in this perspective as well. When a use case involves a critical activity or describes a complex set of steps with a significant number of exceptions, a more formal approach may be desirable. That is how you should organize a description or use case, by writing a formal use case. In the previous example of ACS DCV, you can see this use case is shown in the next slide over here, which follows the typical outline for formal use cases. So the formal use case contains this goal in context, precondition, trigger, scenario, and exceptions. So the goal in context identifies the overall scope of the use case. The precondition describes what is known to be true before the use case is initiated. The trigger identifies the event or condition that gets the use case started, and the scenario lists the specific actions that are required by the actor and appropriate system responses. Exception identify the situations uncovered as the preliminary use case refined. So the diagrammatic representation can facilitate understanding, particularly when the scenario is very complex. UML does provide a use case diagramming capability for this, which we will be seeing in the next slides. So this is a formal use case which is being written over here. So this is a use case template for surveillance, and we have already seen what is the goal in context, precondition, trigger, and the scenario, as well as the exceptions. You can just go through this formal use case uh, by pausing this video. So I just talk about the diagrammatic representation can facilitate the understanding. So here the one example given of a preliminary use case diagram for the safe home system. So you can see here that homeowner is an actor. This is a system boundary, and inside this there are various use cases which are being handled by the actor and the cameras. This is a primary actor. The homeowner is associated with all these three functions. And camera, basically homeowner access the camera surveillance via the internet, and camera is also providing the input to this. So the configure safe home system parameters and the set alarm, these are the three use cases which are being used over here. So up till now we have developed the use cases, but still there are many requirement model situation in which the text-based information or use cases does not provide you the clear and concise information. For clear and concise information, you can choose from a broad array of UML graphical models. Like one of them is an activity diagram. So we will look into how to develop an activity diagram, and there is a variation in the activity diagram that is called as a swim lane diagram. So we will be looking into these two UML models which are supplementary to the use case. So the UML activity diagram supplements the use case by providing a graphical representation of the flow of interaction within a specific scenario. An activity diagram uses rounded rectangles for a specific system function, arrows to represent the flow through the system, decision diamonds to depict a branching decision, and a solid horizontal lines to indicate that the parallel activities are occurring. An activity diagram for the ACS DCV use case is shown over here in this particular figure. So it should be noted that the activity diagram adds additional detail not directly mentioned by the use case. Over here you can see a user may only attempt to enter user ID and password a limited number of times. This is represented by a decision diamond, okay, from creative model, which is not being represented in use case. Next is a swim lane diagram. So the UML swim lane diagram is a useful variation of activity diagram and allows you to represent the flow of activities described by the use case, and at the same time indicate which actor or analysis class has the responsibility for the action described by an activity rectangle. So the responsibilities are represented as parallel segments that divide the diagram vertically. Responsibilities are represented as a parallel segments that divide diagram vertically, like the lanes in the swimming pool. You can see it over here. The responsibilities are divided into by using this vertical line, okay, and this being look like lanes in a swimming pool. So three analysis classes: homeowner, camera, and interface. So you can see over here there are three analysis classes: homeowner, camera, and the interface. So have direct or indirect responsibilities in the context of activity diagram. The activity diagram is rearranged so that the activities associated with a particular analysis class fall inside the swim lane for that class. So for example, the interface class represents the user interface as seen by the homeowner. The interface class represents the user interface as seen by the homeowner. So this is an interface class which is being seen as a user interface by the homeowner class. The activity diagram notes two prompts that are responsibility of the interface. This interface has two responsibilities, that is prompt for re-entry and prompt for another view. So these prompts and the decisions associated with them fall within the interface swim lane. Arrows lead from that swim lane back to the homeowner swim lane where the homeowner actions occur. Let us summarize this up till now whatever we have learned. So the objective of the requirements modeling is to create a variety of representations that describe what the customer requires, establish a basis for the creation of a software design, and define a set of requirements that can be validated once the software is built. The requirements model bridges the gap between a system level description that describes overall system and the business functionality and a software design that describes the software's application architecture, user interface and component level structure. Scenario based models depict the software requirements from the user's point of view. The use case, a narrative or template driven description of an interaction between an actor and the software, is the primary modeling element. Derived during requirements elicitation, the use case defines the key steps for a specific function or interaction which provides necessary input to all other analysis modeling activities. Scenarios can also be described using an activity diagram, a flowchart like graphical representation that depicts the processing flow within a specific scenario. Swimlane diagrams are a variation of this activity diagram, illustrate how the processing flow is allocated to various actors or classes.